Good morning, students. I wanted to give you a little bit of a talk today about the Milestone 6 because this tends to be an assignment that students struggle with a bit. And often I'm told this is the one that takes the most time. So I want you to have that warning up front that you start early this week. Don't put this off. Take the time and to it, get it, and that will make your life a lot easier. Uh, the core idea is that we're pulling this Circle Register DLL into our project. So this is an outside library that represents a cash register suite. Well, so the cash register drawer, the credit card reader, and the receipt printer gives us those functionalities. But outside library, it's not one that you're going to write. You don't have direct control over how it's structured. And that means you're going to have to make some adaptations to be able to use it. And this is very common in industry that you will run into that. And basically what we're doing is we're implementing the completing the order functionality is really a big chunk of today for this milestone. So you get the choice of how you're going to deal with payments. Present the user with the option of paying with cash or with a credit debit card. Uh, Credit debit's actually pretty straightforward. The DLL has a card reader object with a static run card method that you can invoke to read a card, and that will talk to the credit card reader and handle all of the parts of that. All you really care about is what result it gives back to you, which is one of these expiration values. Either it was approved or it was not approved for one of these reasons. And depending on what the reason is, you need to share that with the operator of the cash drawer so that they know to tell the customer, oh, that debit card had insufficient funds, or oh, you put in the wrong PIN number, and then give them an opportunity to pay, try paying again with a different method or the same card. Uh, so if it's approved, sale is done, print your receipt, you're good, start a new order. Uh, if it, at any point, you should also be able to cancel if, for example, you're not getting your card through and the customer's like, oh, that's the only card I have, so I guess I can't have dinner today. Then cash option needs to have a special GUI for taking cash payment to the customer. And that's a little bit more involved because that cash drawer actually keeps track of the quantity of every kind of bill and coin that is inside of it. This is very standard in a lot of the service industry jobs and the retail jobs where that point of sale will keep track of how much money is in the register, should be in the register. At the end of the day, they'll count out the drawer, the actual change and dollar bills that are in the drawer, compare that to what the point of sale says. And if there's a discrepancy, if the drawer is short or if the drawer is long, then that often involves some retraining of employees and usually treated as a fairly big deal. So we need to keep track of that so we can process. Now the other thing is this cash register drawer that we have doesn't implement things like the iNotify property interface. And because it's not our class, we can't force the company that makes this drawer to go add that to it. We're going to have to deal with that. We're going to have to adapt to it. And the best way of dealing with that is actually to write an intermediary class, a model view class, in the model view model discussion that we had for this week. And that means that you're going to write a class that sits between the DLL and your GUI that provides that functionality you need. So the ability to apply when properties change, as well as keeping track of how much change has been made and all of that kind of detail. So I suggest you have several properties, one property for each denomination of currency to represent how much of each is in the drawer. And that's already in the round register DLL, but you need to wrap a property around. So that is the first one. Second one is for all the same denominations, but to represent what the customer is paying with. So what bills and coins is the customer handing the cashier? And the third is properties represent the kind and quantity of currency that should be paid back to the customer as change. So if they give you a 20 and their bill was 8.50, then you need to give them back a 10, 2 ones, and 2 quarters. All right. And the making change algorithm you're going to write as a part of this intermediate class. And to do that, you also need to be aware that when you're making change, you better have that change to give in the drawer. So in that last example, if your change algorithm tells me I should give the customer a $2 bill and there's not one in my drawer, that's a problem. So you should also reference the fact that you have a count of what should be in the drawer. It's that. Um, so here's kind of my suggestion for what that GUI could look like, where you can plus or minus what you're getting from the customer and calculate what you're supposed to give as change. And these can just be bound to those properties in that view model class that you're writing. So that makes it a lot easier. The other thing I strongly, strongly suggest you do is, rather than writing this as one big control, start by writing a control, a custom control that's just one row out of this table, which represents a single quantity of a single denomination. And if you write that as a custom control that implements its own custom uh, data uh, dependency properties, then you can bind to that just like you've done the other controls, like treat it like a text box or whatever. And now you can build that control, and instead of having to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 sets of the same code, you write that code once and you just get to use it everywhere. Much easier. It's kind of like inheritance. So go ahead and do composition with it of simpler controls that you've built yourself. And then you need to show the information about how much it costs. This is kind of the example of what that component is. And then you need to print the receipt. We don't actually have a physical printer. We're not going to print on a physical printer. So instead, what it does is it spits out a receipt.txt file, which is going to be in your binary folder. If you're running a that will be in the D folder. If you're running in release, it will be in the release folder, and that will basically have all the lines that you've printed. Plus, when you set that tape, it's going to do a dashed line across the bottom to show where that receipt was cut. Go back and check that. Make sure that your receipt is printing correctly. And note this is especially important. Each receipt line cannot be longer than 40 characters. If more than 40 characters, it's off the tape and it won't be printed. And that means it won't be in the file. So if you put your amount over on the side and 60 characters over, there's no amount on that receipt. So you need to make sure that those lines are no longer than 40 characters as part of your testing and development process. And then you are going to test that cash payment processing. One of the nice things about MVVM, you've got that view model, and you can test that view model directly. The cash drawer between each test, invoke the reset method that puts it back at the opening amounts of bills so that it's always consistent. And then for testing the GUI, you're going to write a test plan, kind of following the same stuff that we did in the module on testing with WPF applications. So write a test plan that you could give to a software tester and fire up the point of sale, walk through it step by step, and verify that it's all behaving. That's often how we test GUIs. Even now, we don't have necessarily great automated solutions for testing GUIs the same way we do other kinds of code. So that's pretty standard. And usually students want some examples, so I'm going to show you a couple example projects from prior semesters so you can kind of see how this would work. I'm going to start with this one. So here, this was a breakfast restaurant, so we're going to add some items to our order. And once we're finished, we can come down to complete the sale, and notice there's a cash option, a credit debit option. Let's do cash, and he or she implemented kind of the same control that I was showing to you. So we owe 1176, and notice here we have some extra decimal points after the decimal. This is because they were using doubles and not decimals. Doubles introduce floating point error when we do multiplication and division, and obviously we're doing multiplication to get the taxes, and that is why there's extra zeros there. Fix that with some formatting, but honestly the best way of fixing that is just use a decimal instead of a double. All right, so we owe 1176. So if we paid with a 20, we owe 824 and change. And notice that we are saying, oh, we need to give a $5 bill, 2 dimes, and 4 pennies as change. So that's kind of the idea of how that should work. And if you finish that, then you should move on to a new order. Notice now we're on order 3. We're done with that one. All right, show you another example. And this student, a different semester, had maybe chicken, which is a chicken sandwich, and a baked bean side, large, and soda, sarsaparilla. And then we can go ahead and complete that order, and notice we have a nice big pay by credit card, by cash, and they also pulled out the details and nice large text to say this is how much we owe. They even showed us what the sales tax rate was, which is a nice touch. And if we go to their pay by cash, notice this student did it a little differently. He actually split this up into several steps. So we start by taking the amount from the user, so maybe it's a 20, and say I had some change, they gave us 3/4 and 2 dimes. All right, so now you can see we've got our total received. He's got an add to drawer button. If we click that, then it goes ahead and tells us what we need to expense. And notice that he's telling us we need to give 110, 3 pennies, and 1 nickel. So he's kind of reusing parts of this GUI. Basically, he took the way that we did it, I suggested, and kind of split it into 2 steps. That's perfectly fine. Again, we want to format this so that we're only showing $10.08, not the very, very small fraction of a cent that's out there. And we do the finish, and it went ahead and printed the receipt. If we wanted to see that receipt, like I said, we can come into our solution, open the folder that is in, and jump down into sale, binary folder, debug folder, and we drill down and notice there's our receipt right there. And we have order 1, all the details. Now this student did not actually cut the receipt, so if you cut the receipt, there should be a line of dashes, and then the next order you do would be underneath. So that's kind of what we're going for. Hopefully that clears up any questions you might have and gets you in good stead. Remember, start this one early. This is going to be potentially a challenging one because you're building those dependency properties in a very large cache GUI. The rest of it's fairly straightforward, but it is time consuming. So be sure that you start early. And good luck.